Okay, for today, this is called linear programming. And we are going to do a problem from beginning to end, and there's lots of little parts to the problem, okay? First, you need to write down the basic details, okay? I'm going to start a little store, and in that store, let's say it's going to be located in our building here, and they're going to sell only 2 items just to keep our life simple. They're going to sell Apple pencils, and they're going to sell calculators like TI-84s. Because every now and then people's calculator breaks, they can just buy one at the store, okay? All right, so we're going to have two things. That's the first thing you have to do is define your variables. We're going to say x equals graphing calcs. Y is going to equal Apple pencils. Next little factoid. When we sell a graphing calculator, do you get the whole point of having a business is that you make money? So you buy them for a certain price, and hopefully you can get a little discount from them when you buy them so that when you sell them, you make a profit. Okay? So if you buy calculators for 120 bucks and you sell the calculators for 120 bucks, you're a pretty bad business person because you're making $0. Okay? Now if you can convince the store to, sell you 10 calculators at a time and you get them at a discount or something, then you can sell them at the normal price. Point is, we're going to make a small profit. Okay, so on our graphing calculators, we are going to make $10 profit. I've got a visitor here. I'm going to pause for a second. Okay, so Apple pencils. We're going to say that Apple is so tough to deal with. It's true. In our school district, it was hard to get any discount at all. We would buy like 3,000 iPads, and they would give us like no discount. They're really tough because they know that they have what's called pricing power. They're so popular that they can afford to not give any discounts and people will still buy their stuff. So they are an extremely profitable company. But that means it's harder for us to make a profit on stuff. So we're going to say we make $5 profit on each of the Apple pencils that we sell. Now you can write what's called a profit equation. You should be able to do that right now without my help. I'll just give you this hint. Start with P equals and write the profit equation. If you don't have the P equals, it would be marked wrong. All right, I'm going to pause for a second while you try to write that equation, and then check with the kid next to you and see if they got the same thing.
Yeah, that makes sense.
So typically kids are going through this. Isn't it just x plus y? No, but then you haven't included the profit numbers, right? So what do you
He
do?
wants a profit.
10x
Y plus 10.
5y. Raise your hand if you had that one right. Good. That's how much you will make. And now just imagine for a moment that at the end of the day of sales, you had sold 3 of each. You would go 10 times 3 plus 5 times 3, and then you'd say 30 plus 15 is 45 bucks. We made 45 bucks profit. That make sense? All right. Okay, so that is the process of writing a profit equation. It could also be called an optimization equation. So if you hear either of those 2 words, profit equation or optimization equation, that's that part of the problem. Okay. Next, we have to actually graph something. Now, one of the things that's kind of weird is that you do not graph that equation that we just wrote. You never graph the optimization equation. You graph other things. And we already defined our variables, so you should be able to define the labels on the x and the y-axis. Would you please do that? Make an x-axis and a y-axis and label them. You know that one of them is not time. I know a lot of times graphs have time on them. This graph has x and y, and you know what x is. Some of you are just sitting there. Get back to work. Can't zone right now. No zoning. Label the x and the y-axis. All right. You should have figured out that since x was graphing calculators, and here's where x is, this is the graph calcs. And then over here, we have y, and y is the A pencils. I'm fine with abbreviations, but you have to label your stuff. Okay. Now, I hope you figured out that this class is a lot about lately, it's a lot about graph something, shade on one side of it, grab something else, shade on one side of that, and then when it's all done, you have this region. Do you remember what that was called? The what? Feasible region. Very good. And do you remember where I told you the answers would always be? The vertices, the corners of the feasible region. All right, that's the part we're going to do next. But they aren't just nice enough to tell you, hey, here's your equations. You have to write them. And they don't call them equations. They call them constraints. Do you get that sometimes businesses, even though they could sell a ton of something, they don't have that many? Like, for instance, Verizon is about to launch the first 5G phone. Okay? And it's going to be really popular. Have you guys heard of 5G yet? Okay. Have you heard of LTE? That's like a fairly fast network. Okay, well, this is 10 times faster than that. So imagine you click on something and it gets there before you've even lifted your finger off your phone. Okay? It's like goes really, really fast network. Boom, 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 boom. So anyway, 5G's coming, and within 2-3 years, everybody will have 5G. It'll be no big deal. But right now, nobody's got it yet, and Verizon's making a big deal about we just launched this. But do you get? They might have 100 customers come in, and they only have like 6 phones. So like the first 6 people get them, and the rest of them, it's like, sorry, we'll call you when we get more phones. That's called a constraint. Because in the real world, you might be able to sell tons of something, but you only have a few. Same thing happens with Apple. They, on purpose, we think, sometimes don't give that many phones to their stores, and that creates this like, ooh, I need to go get one, because they don't have any. You know what I mean? They must be really popular. And so it can almost create an artificial demand for them because they're hard to get, therefore they must be really cool. Okay, so anyway. We're going to say a constraint on our system is that we don't have that many Apple Pencils. We only have 10 Apple Pencils that we can sell in a given day. That's a constraint. Write the equation for it. Remember which one's Apple Pencils, and then remember what that means when I say less than or equal to 10. If any of you just wrote y equals 10, you kind of had the right idea, but we're not going to just automatically sell 10. Y equals 10 would imply I'm going to sell 10. But y has to be less than or equal to 10. Raise your hand if that's what you wrote. Good. Now, graph it. All right, so I don't know where y equals 10, but I'm going to say that that's 10 for me on my scale. And then I draw a line there, and then I'd shade underneath it. Raise your hand if you did that right. Okay, good. Next, we're going to have another constraint. Do you get that we can't, even if we can get tons of graphing calculators, let's say that our little store can't, like we don't want to store like 1,000 of them. We want to have a reasonable number of them on hand. Stores don't want to have a ton of stock. They just want to have enough. So we're going to say that we're going to only keep 20 graphing calculators on hand at any given time. Even though we could have more, we don't have room for more. So we're only going to stock 20 graphing calculators. That's an equation. Write it. X less than or equal to 20. Draw a line, shade it just a little bit. In my opinion, you don't go shading forever all the way across the graph. Just makes it messy and hard to find the important spots. All right, and the last one, the last equation we're going to add here is a realistic, like, past experience thing, where do you get, if you every day at your Slurpee shop you sell like 3 of the raspberry for every 1 of the cherry, that's probably going to keep going. You know what I mean? if the raspberry is the popular one, you're probably going to keep on selling more of those. Okay, so here's a statement that's harder to write the equation for, but you're going to have to do it on the test, so we're practicing now. We typically sell twice as many Apple Pencils as we do graphing calculators. There's an equation for that. Twice as many Apple Pencils as graphing calculators. I'll give you a reason. At school, do you get almost every kid already has a graphing calculator? Okay? And yet only probably 10% of the kids have Apple Pencils. And so as Apple Pencils get to be more popular, we're going to probably sell more of those because everybody's already got a calculator. You could argue it the other way and say kids don't need an Apple Pencil, but they really need the graphing calculator. But I decided to go with we're going to sell twice as many Apple Pencils as graphing calcs. All right, I bet you 3/4 of the class just did this wrong, and let me show you what the trap you fell into. Some of you, first of all, be honest. How many of you don't even have an equation yet because you don't know what's going on? It's okay. All right, that's normal. Okay, then there's a lot of you that went like this. Twice as many, and then you went Apple Pencils. That's not it. And a lot of people did that, and I totally get that. But let's think for a second. Let's actually use some numbers that is twice as big. Let's say we had 10 Apple Pencils. Then I'm going to put a little 10 into your equation that you thought was right. And then there should be, if there's 10 Apple Pencils, there should have been 5 calculators, right? If it's twice as many Apple Pencils. So do you doubled the wrong side? I know, counterintuitive. It's not what you'd expect. It'd be like a world in which you eat more ice cream and you lose more weight. Like, what? That would be a great world. I'll be like 6 ice creams a day, baby. All right. So, you should have said y equals 2x. I know that's counterintuitive. I said twice as many Apple Pencils, but if you actually stick in numbers then, I put in 10 here and 5 here, it works. Look, 10 equals 2 times 5. So be careful on that one. A lot of people are going to goober that one up. All right, last thing is we're going to say less than instead of just equals. Now, I never said that, but I'm going to say it now. We're going to make it y is less than 2x. Less than or equal to. And that means like, okay, would it be a feasible combo if it's really a less than thing to make this like 12 and 2? Does that work in my equation? Is 12 less than or equal to 4? No. So that means that it's not like, okay, that's not a 6-to-1 ratio, like selling way more Apple Pencils isn't realistic. So what we're saying is less than double. You know what I'm saying? It's less than double. Or it could be double. It's double or a little less than that. Okay, so there's our y is less than 2x. Would you please graph that? How the heck do you graph y is less than 2x? What if I said 2x plus 0? Would that help? That's showing you the y-intercept and the slope. Hint, hint. Slope of 2, y-intercept of 0, less than means shade underneath it. If you look up at the board, do you see my green line there? Should have been something like that. Does that make sense to you? Or you just zoomed in so far that I can't see your graph. Okay, good. All right. Now, one more equation. if I do the feasible region right now, let me show you what happens. What's unrealistic about that? You can't have negatives. Would you please tell me what the equation is then for that? Yes.
What if the x is greater than or equal to 0, and then y is also greater than or equal to 0?
Okay, let me show you. Okay. If I include both of those, here's where x is greater than or equal to 0. That'd be this line and bigger. But that one really doesn't even matter this time. You know what I mean? Like, we aren't going to possibly stray over there because we have to stay under the green line. So just do the other one. Which one is the other one?
Y is less than or greater than or equal to 0.
Y greater than or equal to 0 is correct. I'm putting that in my list of equations. Y greater than or equal to 0, I'm going to do with the yellow line. Shading above it. Now I got my feasible region. Do you remember me telling you where the answers were always going to be? The vertices. The answers for what? Well, what's shaded here is all the possible combos that our little store might sell. You know what I mean? Is 3 x's and 1 y a possibility? Yeah, it's right. It'd be right there about. Do you get how 3 x's and 1 y is a reasonable thing for our store? Would 20 x's and 1 y be a possibility?
It's like
Yep, it's right on the edge. That's possible. How about 21 x's? No, it's not feasible anymore. Okay, all right, but why are the answers at the corners? Because the answers are at the corners because that's where you're going to optimize your profit. Do you remember me telling you that 0, 0 usually gets thrown out because that just means you're not even going to open your store? And that's just sad. Okay? So it's either going to be this one, or this one. Those are the 3 possibilities where you'll make the most money. In this case, I can just use logic to tell you whether it's A, B, or C. Can you? Think about it for a second. Don't say it out loud. I don't want you to bias because once the smart kid says, oh, it's C, well then everybody's going to think it's C. Don't give the answer. Think. Which one would you advise the boss to go for? The one that makes you the most profit. And which one makes the most profit? Okay. How many of you think it's B? Raise your hand if you're right. Because you are right. All right, good. B is it. That makes the most profit. You know why? Because you sell the most stuff. Now, sometimes it's more subtle than that. You can't tell just by looking. Let me show you an example. You do not need to take notes on this. Just imagine for a moment that the graph kind of looked like this. I would know, if this is my feasible region, that that can't be it. I would also know that that can't be it because this spot sells way more. Here's X's, here's Y. This spot sells more X's and more Y's than that spot. So that has to be better. But which one's better between this and this? I'll call it A and B. Which one's better? Well, it depends is the right answer. What if you make lots more profit on your X's than on your Y's? Then B is going to be great because you're selling a lot of the thing you make a lot of profit on. Okay? Versus A would be, well, you might sell some of each, but you're selling a lot of Y's, and if Y doesn't make you much profit, who cares if you sell a lot of Y? All right, and last thought on that is, there are some real-world constraints that aren't just about profit. Do you get, if you went to 7-Eleven, how many of you guys have been to a 7-Eleven before? Okay, it's like an SA or whatever. Just a little local convenience store. Do you get if they went through and figured out which items make the most profit, and we're only going to stock those 3 items, and all they had was pizza and phone charging cords and oil. You wouldn't even go in the store because you'd know, they don't have much selection. See what I'm saying? So sometimes stores have to price things where, like, even though I'd make more profit on selling the pizza and the oil, I can't just have a store that sells pizza and oil. You know what I mean? So sometimes you have to stock things you don't have much profit on. Okay, so sometimes it's not all about the money is what I'm trying to say. Sometimes you got to think bigger than that. All right. So back to our problem. We got to here, and here is how you would combine the optimizing equation we did at the beginning with this. You remember this P equals 10x plus 5y formula right here? You would be asked to tell what would the profit be at A, B, and C. How much profit do you make at A? Well, then I got to figure out what exactly is that point. If I knew that point was like 8 comma 10, then I could figure out how much profit it had, right? Do you know that it is 10? Isn't it 10 high? It is 10. So then we just got to figure out what the x is. So how do you find a spot where two lines cross? That's called solving a system of equations. So let's go off to the side here and say, what are the two equations we have to solve to get A? We have to take the green equation, which was y is less than or equal to 2x, and put that with the other equation, which was y was less than or equal to 10. Next thing is, you don't worry about the less thans, you just worry about the equals. Because where two lines cross, that's where they're equal. Okay? So then this is y equals that and y equals that, and then I do substitution, it's called. If y equals 10, can I just put a 10 right here? And then it's 10 equals 2x. X must equal what? Do you get how that point then is at 5 comma 10? That goes on my list of possibilities. 5 comma 10 is one of my options. 5 comma 10, and here's profit. 5 comma 10 will get me how much profit? I put the 5 in here, and I put the 10 in there, and that's going to be 50 plus 50, which makes $100 profit. Would you now figure out where point B is? It's pretty easy. And then put it on the list of options and find out how much profit it has. And then find point C, put it on the list of options, find out how much profit it has, and compare A, B, and C. 0, 0, we don't even check because it's a no-brainer. But compare the profit you'd have on A and B and C. That is a problem from beginning to end. I'm going to pause for a minute while you finish this up. Okay, so the profit amounts. First of all, it was 20 comma 10. Raise your hand if you knew it was 20 comma 10. Awesome. And then the profit you get for that spot, well, you go 20 times what? 10. And then 5 times 10. So that's 50 and 200. Do you get $250 profit there? All right. And then the last spot, which would be 20 comma 0. Well, just logically, can you see that's going to be less profit? It's going to have to, they don't sell any of the Y's, which would be the Apple Pencils. So they're only making 20 times the 10 is $200. There we go. That was the best. All right. Now, let me just sum up with one last thought. It is very typical to have two lines that are like tilted, you know, not just like straight lines. And you have to see where they cross. What do? You take both equations. Let's say this was y equals negative 2x plus 12. And let's say this was y equals positive x plus 8. And you have to set that equal to that. And then solve the equation. That's the main thing for today. See, the nice part is, I know that took a long time, but that's a full problem from beginning to end. And typically on the test, there might be only one problem that you do from beginning to end. Okay? One problem. That's not the whole test is one problem. It's just there's only one problem that you go have to do the whole thing. A lot of little pieces, like here's the vertices. Test and see which has the most profit. That might be a question. Another question might be, just graph these 3 lines. shade in the right spots to find the feasible region. That's a separate question. Okay, so the little pieces of this, the little individual skills are separate, like R2s and R3s. And you might only have to do one from beginning to end. All right, so your homework for tonight has a lot of this. Find where these two intersect. It also has some of write these equations. Do you remember that thing that almost everybody had wrong? I'm going to do one more like that. Cats and dogs. If you go to the animal shelter to pick out a used pet, what? Used? What are you talking about? Well, people buy used houses all the time, and they don't call them used houses. Usually we call it like a shelter pet or a rescue animal. Anyway, you're going to go, and by the way, my family only bought those our whole lives. So, and that my mom and dad, always picked out dogs. Do you think that's the more common, or do you think cats are more common? Dogs. So I'm going to give you an equation. You see if you can write it. They typically give away 5 times as many dogs as cats. Use D and C. D for dog, C for cat. And don't screw up the equation. A lot of people do. 5 times as many dogs as cats are rehomed, is a nice way to say it. All right. 5 times as many dogs as cats. No. Let me prove it one more time. What's something that would be 5 times as big? If I had 10 dogs, then that would be like how many cats? 2. And do you get that equation says 50 equals 2? See what I mean? The 5 needs to be over here. That makes sense. Okay. What if I said it's a little less than 5 times as many? Now, what if I wanted to make sure I was right? What would be a combo of dog and cat where it's a little less than 5 times as much? How about 9 to 2 versus 10 to 2? See what I'm saying? Now we got to see if that actually works. That's the best way to check these, because it is common for people to mess these up. 9 is less than 5 times 2. Is that true? Yes, so it worked. So you find a combo that's a little less than 2 times as many, and you see if it works in your equation. If it hadn't worked, I'd have probably just had to switch this around to the other way. A less than versus a greater than. All right. I get that. That is complicated. We'll do one more just for the fun of it. Let's say sharks versus buffalo. Which do you think kill more people? Buffalo. Way more. Seems crazy, but it's true. Typically only 6 people a year die from a shark attack. All right, so buffaloes versus mosquitoes. What do you think's more? Mosquitoes. All right. Humans versus buffaloes. Humans kill more humans than buffaloes do. Yes. Okay. Now we'll do one. Spiders versus snakes. Let's say it's 3 times as many deaths from snakes as spiders. Write the equation. 3 times as many deaths from snakes as spiders. And I'm going to use S for my variable, but watch out for S's because they look like 5s. So again, common mistake. 3 times the snakes equals spiders. That's another bad. I'm going to go with P for spider. All right. So 3S equals P. Nope. It's the other way. S is equal to 3P. I better check it to make sure. Let's say that I say snakes. This is snakes. Was 10 snake deaths. And let's say 10 isn't going to be divisible by 3. So we're going to go with 12. So 12 snake deaths and let's say 4 spider deaths. Is that a 3-to-1 ratio? Yeah, it is. And my equation worked. Yay! So you can double check yourself that way. So I'm going to make one last change. It's actually a little more than 3 times as many deaths from snakes as spiders. a little more than 3 times as many deaths from snakes. S greater than or equal to 3p. Let's say that's what I think it is. Now I'm going to go off to the side and say snake deaths versus spiders. P is the main variable there. And if it's a little more, then it'd be like a 13 to 4 ratio. That'd be a little more than 3 times as many. Now I'm going to put the 13 in the snakes and the 4 in the spiders. And is 13 greater than or equal to 3 times 4 is 12? Yes, it worked. Sweet. That's how you can check yourself before you wreck yourself on the test. All right. So, what's your homework? It's a worksheet. There's 4 problems. You skip the 4th one. That's cutting off 25% of the problems, right? And do the first 3. I will get the first one started with you here. Pause for a second. All right, so this is about a parking lot, number 1. And the area of the parking lot is 600 square meters. Eventually, I'm going to have to write equations for this. So let's try to do that. That's the hardest thing. They're called the constraints. Would you read me the part about the cars?
A car requires 6 square meters.
And how about the other thing, the buses?
Bus requires 30 square meters.
Okay. I'm just writing down all my important facts. And then I better pick X versus Y on cars versus buses. Do they tell you what should be what? Do they say X is cars or something like that? Does it say that in the problem? It says it on the graph. Okay, awesome. So then, since it says it on the graph, tell me, what was X? Cars or buses?
Cars.
All right, so X equals cars, Y equals buses. That's all important. That's called defining the variables. Do you have a spot for that on your equation worksheet, or on your worksheet there? I think it does, doesn't it? Yeah, so you say X is cars, Y is buses. All right. What's another spot on here? Read me that one.
The constraints.
Constraints, okay. That's an equation. All right, would you agree that we have to get some number of cars plus some number of buses into, but wait, if I say equals 600, what I'm saying is the number of cars plus the number of buses is 600. That's not what I want, is it? Who can fix this a little bit so it'll be right? Yes, sir.
It would be 6x plus 30y equals
6x plus 30y. Now I've changed it into, instead of how many cars, it's how much square feet the cars, or meters, sorry, that the cars take up. 6x plus 30y has to be equal to 600? Do you have to have a car in every single spot in your parking lot? No. So then maybe she should say less than or equal to 600. There's one of the constraints. How about a common sense constraint about cars? What can you tell me about all X? X has to always be, very good, greater than what?
greater than or equal to
0 is what you said, I think, right? Okay, it's just a little quiet. Yes. X is greater than or equal to 0. Give me another equation that's kind of like that.
y is greater than
Y has to be greater than or equal to 0 also. The buses has to be, well, does it say you have to have a bus? No. Could be 0, but it can't be negative. That's the main thing it's saying, is X can't be negative, Y can't be negative. Okay? Is that the only other thing? Is there any other equations we have to write? I'm not saying there is, I'm just asking. Yes?
There's like the thing about the attendant. He can
Ah.
handle 60 vehicles.
Okay. So the attendant, can you say that one more time?
He can only handle 60 vehicles.
60?
Yeah.
All right. Then, what do you think the equation is for that one?
X plus y is less than or equal to 60.
Yup. That's, he can only take the number of cars plus the buses has to be less than or equal to 60. That make sense? Okay. And that was actually about how many cars there were, so we didn't have to put numbers in front of each one. If it was really about area, we'd have to put the number in front of each X, like the 6 and the 30. Okay. And if we graph all of these things, hint, I would solve them all for Y. Except you can't solve this one for Y. You just have to know X equals 0 is the Y-axis. This one's already solved for Y. I would solve this one for Y, and I'd solve that one for Y, and then I would graph them. But in this case, aren't they already graphed, I think?
Yeah.
Okay. In a real problem, you'd have to solve them for Y and graph them. But hey, we've already got them graphed. Awesome. Then what's left? The optimization equation. That's that deal where we figured out how much profit we're going to make. Would you tell me, sir, how much was the profit on each X? In this case, it might not be profit. It might be like income.
It says if a car is charged 250,
2.5.
2.5, and a bus is 7.5.
And what will that equal? Remember, I've said before, you can always just say it's equal to profit. Or in this case, it's not technically profit. What is it? Income. I'd have accepted P, but technically, if you're really into business, you understand that how much money you bring in, all it really matters is how much profit you have. Like a grocery store might go through $1 million a month, but they don't have that as profit. They might only make 10,000 of that as profit. Okay, so the income here is 250 for each X, 750 for each Y. This is the one you would never graph. You don't graph the optimizing equation. You just take the corners of the feasible region and put them in it. Can you tell me one of the corners of the feasible region? Well, 0, 0 is probably up there. Do you get I've told you can just throw that one out? Because it's going to get you 0 profit. If you don't park anything in your lot, you get 0. I actually know a family who owns a parking lot. Kind of a weird concept. They just have people park in their lot, they get paid, and then they do monthly contracts. So it's so weird because we don't, around here where we live, there's not much of that. But if you go into Minneapolis or St. Paul and you want to work in a building and then there's a parking spot right across the street, it's pretty sweet. And you're willing to pay like $60 a month to have this parking spot right across the street from where you work. Because otherwise you got to walk through this ramp, and the ramp might be a little cheaper, but anyway. So my friends have this parking lot. Anyway, it's kind of a weird thought of a thing to invest in. All right, then you'd have to figure out your options and then how much profit they make, or in this case, income. I'd be fine with you changing that to profit. Something comma something will give you how much profit. Something comma something will give you how much profit. All right, that's how you do it. You have problems 1, 2, and 3. And there is a key, so don't forget to check your key. You can be perfect. I need something in the grade book soon because we're in a new quarter. And parents go look at the grades every now and then. And right now it would say nothing. And then sometimes I get the email. It's like, how come it doesn't say anything for Jimmy's grade? Because we haven't put anything in the grade book yet. So I got to put something in soon. So get your homework done. Any other questions? By the way, if you're looking for the top 20, it's going to be in there. But I wanted to put in the first homework assignment first because some people got like 14 out of 20, and I didn't want that to be your grade without anything else in there to kind of cushion it. So I'm putting in the top 20, and there is unlimited retakes in the top 20 if that did not go well for you. If you weren't here to take it, you're welcome to take it whenever. It takes 20 minutes. Take it after school, before school. Okay. All right, that's all I got for you for today.